Hello, and welcome to this PS3 Learning Set 1 review for the test, and it's for lessons 1 through 3. What makes it start and stop? So we're going to go through a quick review here. I'm not sure exactly how long it'll take. It really depends on how in-depth I go through and explain the questions. Now, are these questions going to be exactly the same way they're on a test? No, but all the concepts are the same. So if you really understand what is happening in this video, you will understand and do well on a test. So I certainly hope that you do take the time to watch this video review. Now, one of the things you are going to have to do on a test is you are going to have to create an interaction table. And that's what this is right here. It's basically, well, it's an interaction table. It talks about how all these various things interact. So what I'm going to do is I'm going to get a pen here. And you can't see it. It's actually on top. Well, there you can see it. Well, I got the pen. What color do I want? Okay, I just want to make sure it's working. Oh, there it is. Okay, so let's make an interaction table. Now, we have plus signs are where they interact, and a negative sign are when two things don't interact. So when we go through this, you just have to go through each one. So you have the earth and the ball. Are they going to interact? Well, yes, because whenever we talk about the earth, what we really mean is gravity. And whenever we have gravity, it's going to be pulling down on the ball. It's going to be pulling on the hand, so it'll be the same over here. So, because this is Earth. So how about the hand and the ball? Is that going to interact? So when we look over here, are they interacting? Absolutely. Okay, how about the ball and the hand? Wow, this one was a really simple one. But on a test, are you going to be able to build or create a basic interaction table like this one here? And the one that you're going to see on a test will be one that you've had in class, that you've practiced, that you've had a chance to work with in the past. We're not going to surprise you with something totally new. Now, you have that same ball and that same hand right here. So one of the other things you're going to have to do is you're going to have to be able to draw simple models. So draw a simple model of the ball being held in your hand. Be sure to draw in the arrow showing the direction of the forces. Okay. So I'm going to draw the ball in as a circle. If you wanted to make it a rectangle, you certainly can. Okay, so then I'm going to have a rectangle on top. And what do you think I'm going to label that? I'm going to label that as the hand. And as always, I apologize for my handwriting. Even though I'm looking at the screen, I have to write on a pad that's over to the side. So I'm not actually watching my hand write. I'm watching the screen and my hand's way off to the side drawing these in. Okay, so we have that. So what's the other thing we have to have? We have to have the earth. Now if you want to draw it right there on it if you want, it can all be touching because you still have to draw the arrows. But I'm going to leave some space between here. And I'm going to label this earth because when I do that, it kind of tells me that there's some space between here. And there is. So there's this space right here. It's not directly touching the earth. Okay, so let me draw on some arrows. I'm going to change my colors a little bit. Okay, so we have the hand, and this is the ball, right? Okay, so what are the forces? You're going to have a contact force between the hand and the ball, so I'm going to draw on both arrows. Remember, they come in pairs. They're going to be solid lines because they're contact forces. Now we're going to have forces between the ball and the earth. Let me pick a different color again. Let's go with, how about yellow? Okay, so I'm going to draw these dashed because they're forces that act at a distance. Now the earth is pulling on the ball. Is the earth also, or when we talk about the earth, it's really gravity, right? Is it also pulling on a hand? You bet. So I'm going to draw an arrow way up here. I'm going to draw an arrow down here because remember, they come in pairs. Now is this everything that I need? So do I have everything that I need in here? Absolutely. I have the hand, I have the contact forces here between the hand and the ball. Then I have the forces that act at a distance between the earth and the ball, gravity pulling it down. And then a hand and the earth. So the hand is pulling at the earth and the earth is pulling at the hand. So again, is this going to be the exact one that's going to be on a test? It might be, but I can guarantee you this. If it's not this one, it'll be one that you've worked with, that we've had in class, that you've had a chance to draw. We're not going to surprise you with something totally new that you've never seen before, at least not on this test. So let's take a look at this next question. Here's an apple. So why is the apple sitting on the table not moving? So we see an apple here. It's not moving. And it's multiple choice. So let's go through here. Let's look at the first one. The apple pushes up with the same force that gravity pulls down. The apple pushes up with the same force that gravity pulls down. How about this one? Gravity is keeping the apple down on the table. Well, is that the only one that you would have? How about the next one? No forces are acting on the apple. Okay, we know that one's not true because we know there are forces acting on the table. So what I would do and what I suggest is you cross things off right away that you know aren't true. Just cross them off. How about this one? Gravity is pulling down, but the table is in the way. Well, we know that forces come in pairs, so that can't be true. So now I'm down to 2. So gravity is keeping the apple down on the table. But is that really the only thing? If gravity was the only force happening, wouldn't the apple continue to drop? So that can't be true. So when I look at this, the apple pushes up with the same force that the gravity pulls down. And that's because we have different forces in place. So yes, gravity is pulling it down, but it's pulling back up. We also have the contact force between the table and the apple and the table. So the best answer is number 1. So let's take a look at the next question. So we have 2 magnets here. And if you remember in class, we actually had these in a test too. So it's just a different diagram that you see here. So these are both magnets. So what are the forces acting on the lower magnet? So when I look at this, what are the forces? First of all, we're going to have what? Yeah, we're going to have gravity. And is it going to be pushing or pulling? Gravity pulls down, and that's because of the weight of the magnet. So gravity is pulling this magnet down. Okay, so what are the other forces acting on the lower magnet? Okay, well, if we remember these magnets, you notice how this one's hovering? So this one is pushing up on this magnet, and that would be a non-contact, or that would be, yeah, it would be a non-contact. It would be a force that acts at a distance. But what is this magnet doing? Is it also pushing down? Okay, so we have a push of upper magnet. I'm just going to put MAG on lower magnet. So these are the only forces that we've talked about so far. Now, if we remember in class, there was another force, wasn't there? These were in a test tube. And if we have these in a test tube, there would actually be a third force. And that's the contact force, right, between the magnets in the test tube. So let's say that I added a test tube to it, and these were in a test tube. How would we write that? Would that be a push or a pull? It would be a push, right? So and we can even say push contact force. So it's push contact force. Again, I apologize for my writing. It's really weird writing like that. Push contact force between magnets, and I'm just going to put test tube. So those would be the 3 if we included that. So on the test, again, on the test, I'm only going to ask you questions that you've seen before. I'm only going to show you diagrams that you've seen before. So it might be the one with the test tube. Maybe it's the balloon rocket. Maybe it's the fan-powered car. But you will have seen whatever I ask you about this question. So this question will be on there. I just can't guarantee what it's going to be. Is it going to be the lower magnet? Maybe it'll be the upper magnet. Maybe I'll have the same diagram that you saw in your book. So here's that same device. So different question though. What is the relationship between the 2 forces acting on the magnet? Okay, so what is the relation And this could also say relationship. So what is the relation between it? You know, it could also say what is the relationship between the two forces acting on the upper magnet. Okay, so let's go through them. The one acting upward is greater than the one acting downward. Well, would it be balanced here? If this one was so much greater, wouldn't it just keep going? So let's cross this one off. So what is the relationship between the forces acting on the upper magnet? Okay, how about the next question? Or how about the next choice? The one acting downward is greater. Well, it's not if it was pushing it downward, when it continued to push and keep pushing, and if this isn't going to go any further down because of the table, wouldn't this just continue to go up? So we know that one's not right. Both act in the same direction. Well, if they both both pushed in the same direction, would they be doing what they're doing? Isn't this magnet pushing down? And these should be dash lines if I'm drawing the arrows on here. But aren't they moving in opposite directions? So this gives us this right here. They're equal. And that's why they're hovering, and they continue to hover. So when you remember the magnets in a test tube, when you got it just right, they hovered between. And you saw that little gap in between. So they hovered, within the within the test tube, and there was that little gap in between it, and it stayed like that. It didn't just, go back and forth, but it stayed at one set distance. So they are equal. Now the next question, again, we're using the same diagram, but look, a different question. What are the two forces acting on the upper magnet? So what are the two forces acting on the upper magnet? So the first question asked about the lower. Now we're talking about the upper. So the pull of the magnet's weight and the pull of the magnetic force attracting it to the lower magnet. So what do you think about this? Yes? No? Okay. Well, sometimes if you don't know for sure, let's skip it for now. How about the pull of the magnet's weight and the magnetic force pushing it away from the lower magnet? How does that sound? Well, if you don't know, let's go to the next one. The pull of the upper magnet's weight and mass. Okay, how does that sound? Let's look at the last one. Two magnetic pull forces, one attracting it to the lower magnet and another one pushing it away from the lower magnet. Well, let's look at that one. Two magnetic pull forces, one attracting it to the lower magnet and one pushing it away. Well, that we know is not true because they have to be in opposite directions. So this one would be pushing up and this one would be pushing down. It's not going to be pushing down and pushing up with itself. Okay, so we eliminated one. So sometimes if they're a little tricky, we just have to go through all the choices and start to eliminate. So let's go backward. Let's go again. So the pull of the magnet's weight. Okay, so what's pulling the magnet's weight? Is that your gravity pulling it down? Yeah, so we know the pull of the magnetic's weight is good. So both of these have that. And this one has it too. So now the difference is, and to pull the magnetic force attracting it to the lower magnet and the magnetic force pushing it away from the lower magnet. Okay, so what is this magnet doing to this magnet? Is it pushing it or is it pulling it? So that makes us think about that a little bit. So when I look at this one, I'm going to say it's the pull of the magnetic's weight and the magnetic force pushing it away. So if we remember when we put those magnets together, especially the really strong ones, when we tried to push them together, what did it do? It kind of jerked off to the side. And when it did that, so when we tried to put them together, it went off to the side. So when I look at these, it's going to be the one right here, and to pull the magnetic force attracting it to the lower magnet. So the correct answer in this case, would it be 1 or would it be 2? Think about that. So what did you come up with? So we know they're very same. So the difference is it going to be a pull of the magnetic force attracting it to the lower magnet, or is it going to be the magnetic force pushing it? So is it going to be a push or is it going to be a pull? So when we put those two magnets together, did they push together or did they pull together, or were they pushing away so they slid? So again, remember they slid. We were talking about that. So what do you think? If you're siding with it is a push, you're correct. So again, what I'm trying to do here is show you different ways that you could start to solve these problems. And this one, and this one, they all have the same first beginning. But then I have to start to analyze. Okay, this is a pull. This is a push. We know mass has nothing to do with it, so we can cross this out. So once we start to analyze it, we know that it's 2. Same diagram. So let's read this one. We have to read the question very carefully. What is the relationship between the force the lower magnetic applies to the upper magnet and the force the upper magnet applies to the lower magnet? So what do we know about the force that's pushing here and the force that's pushing here? Are they going to be equal? Are they going to act in opposite directions? Do they get stronger as a magnetic gets closer to one another? These are all questions we had in class. Well, are they opposite? Okay, they are. I did that with the diagram. So we know that's right. Okay, so I'm going to put a little asterisk here. Are they equal? Well, we already talked about that in this review. Yes, they are. Well, do they get stronger as the magnets get closer? Well, think about it. When those magnets get closer, and if you have the opposites, so they attract, when they get closer, are they going to all of a sudden come together? Absolutely. So we know this one works as well, which leaves us with one possible choice. All the above. Well, explain the difference between a contact force and a force that acts at a distance. Well, we've covered this quite a bit in class. Remember, contact forces interact with each other by coming in contact with each other. Forces that act at a distance don't come in contact with each other. And it basically is what it says, because they act at a distance. There is no direct contact between them. How about this? Could you explain why the ball in the free body diagram is moving? So here's the ball. Here's a free body diagram. We've been practicing with this. This one is applying 200 newtons of force. This one's applying 600 newtons of force. We know that this arrow, we've been talking about this in class, is longer than this one. So what would that tell you about where the ball is moving? Or here it says, explain why the ball in the free body diagram is moving. Well, we know it's moving down because the arrow is larger here. It's showing that movement. There's a greater force here. So why is it? Well, I just said, basically because there's a greater force pulling down on a ball. So this might be a ball that someone's holding up and it's really, really heavy. And so you can't hold it, so it keeps going down. And that's because then gravity's pulling it down and you just can't hold it up. So this ball is moving down. Now, if you remember in class, we did something similar to that. We actually had a ball in our diagram, and I was holding it in my hand, and I asked you guys, well, what are the forces? And we talked about contact force with my hand holding up on the ball and pulling up on it. And then we also talked about gravity pulling it down. And in this case, if I was holding in my hand and it wasn't going anywhere, it was steady, there would be no motion. So maybe on a test I'll have that diagram and say, okay, why is the ball not moving? In that case, you would say, well, these forces are equal and they're acting in opposite directions. That's what you would need to say, both those, that they're equal and they act in opposite directions. Well, I'm going to give you a hint. I'm actually going to ask that question on the test. I'm going to have you do the ball, but these diagrams, these arrows are going to be equal. So I guess this is one of the benefits of actually watching the video versus not watching the video. You actually know what exact question this is going to be on a test. But on the test, it's going to explain. It's going to say, explain why the ball in the free body diagram is, and all I'm going to do is add, oops, sorry, I can't spell tonight, not moving. So you're going to see that on test. So you just have to explain that these two are equal forces and they move in opposite directions. So that's why it's a balanced force and the ball is not moving. Well, that does conclude the end. Now there's only one video, so the video is a little bit longer, but there's not two videos to this one. It's just one test, a front and back. So again, hopefully you watch this before the test and you don't wait till after the test to watch it because you have to take a review because you didn't do well on a test. So as always, if you have any questions, any concerns, Just ask in class. I'll do the best I can to help you. Thank you, and have a good night. Have a good day, depending on when you're watching this. Bye.